So I'm really excited to actually start this new series on security training for developers, and actually I'm gonna start off by actually saying a great thank you for this to Hacksplaining, because they are actually going to provide the basis for this series and for what I'm actually going to go into in the next videos. Now, of course, this video is not sponsored. I just checked for different places online where to actually try to go through such training and actually post it or try to teach it on YouTube, because the best way to teach something or the best way to learn something is to actually teach it yourself, and one of those is Hacksplaining. And as I've checked, there is no issue in going through these videos on my YouTube channel. If there is, I would actually ask anyone to point that out, or even those who actually own Hacksplaining to actually point it out to me that I shouldn't be doing this. But anyways, security training for developers. This is really interesting and really important if you're into application security, which is something that I'm very into. And that's the reason why we've stopped with the previous series from Try Hack Me, because once we've finished with the Burp Suite videos, which was about 19 videos, I decided that I wouldn't take a step further, because the next step would have been network security. So that wasn't the point. Maybe at some point in the future, but right now, no. Right now we are on Hacksplaining. They also have a book. The book is available on Amazon and of course on, I believe it's No Starch Press by Malcolm McDonald. So I have this book and I'm actually really excited to go through it. Maybe I'm gonna do videos from the book or with the book or explaining concepts in the book in future videos, whether or not this is on demand. So Hacksplaining, as we've seen, security training for developers. What I love about and why I decided, one of the major reasons that I decided to actually do this is because the word interactive. I love the word interactive, and I love the word of actually having to be able to do everything in the browser in an interactive way. And this is what Hacksplaining is all about. Learn how to protect yourself with real up-to-date code samples. So I'm actually going to take this approach, or I'm actually going to take a double perspective in this situation. A perspective of an attacker or a red teamer, for example, an application security penetration tester, and also the perspective of a blue teamer or someone who's actually defending stuff. And of course, with the lens of developing, with the lens of coding as much as I can, and as much as experience I can share from my own background, of course. Now, we've seen the features here. They have 234,000 users and counting. I might be one of them. And completely free, utterly compressive. Let's actually look at the lessons. So, and of course we have the OWASP Top 10 and PCI DSS compliance. That's for payments and card processing, or cards and payment processing. Now, the lessons, as I might have nudged in previous videos, there's a lot to talk about, and that's why I actually love this. So we're probably going to start with the Sql injection, and then we're going to go through cross-site scripting. So we're going to start them in sequential order. As you've seen, cross-site scripting is sort of like grayed out, as well as directory traversal, but which actually means that I think it means that I've completed them. But we're actually going to go through them one more time, and we're going to start with the Sql injection. Here we have the exercise, the prevention, and the quiz. The exercise actually gives you the code perspective on where the vulnerability is. The prevention is, I would say, more like geared toward blue teamers, but I would also say that if you're a red teamer, there's a lot of great insight to learn from the preventions, because you would know what to look for. And then of course there's a quiz. So let's start with the exercise here. see what it is all about. If you're vulnerable to SQLi, attackers can run arbitrary commands against your database. So that's actually really important to know. This is a vulnerable application we will be trying to hack with a SQL injection attack. Now, as a parenthesis here, I don't understand why there is not much content on YouTube with respect to Hacksplaining, because this is an outstanding platform compared to a lot of others that are out there. So we will be trying to hack with a SQL injection tag, and if we click on SQL injection, so it actually takes us to the next step. Here are the application logs. Watch what happens here when you interact with a vulnerable application. So go ahead and try the following try logging in with the following credentials. So we have the user at email.com, and we have the password, and then log in. Let's see what happens. Okay, so guessing the password didn't work. Let's try adding a quote character after the password. So if we look into the logs, checking supplied authentication details for username, finding user in database, so this user actually exists or not, because no such user report this to the user invalid credentials. Now, as a side note, this is a really good generic message, unknown email or password. Or I wouldn't say that it's the best, because in this situation, if you're doing a penetration test, the best way, so I would actually tell them just say invalid credentials without saying unknown email or password. If you say invalid credentials or incorrect login, that doesn't say anything about whether or not the user exists or not, or whether the email exists. This can lead to a vulnerability or to a sort of like weakness or information leakage called like user enumeration. Now, if you're into bug bounties, most of the programs will not accept that. But if you're doing penetration testing like me, that's a valid finding. Alright, so guessing the password didn't work. Let's try adding a quote character after the password. So again, user at email.com, and then we have password and a quote character, not a tick character, but a quote character. Now let's log in. Let's see what happens. Checking supplied authenticated details for user, finding user in database, an error occurred. Now this should only happen in the backend. You should not signal errors to the user or even say an unexpected error occurred. Like I said, it's better to say invalid credentials, and you should actually say this in the logs so that the administrators, the managers, the developers, or whoever is handling the application would actually see that someone actually tried by mistake or intentionally, like in the example of an attack, tried to force a SQL injection. Syntax error. Unterminated quoted string at or near password limit 1 line blah 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 blah. So this is a SQL error message. The application crashed with an unexpected error. What could that mean? Well, the logs show a SQL syntax error. This indicates that the code character messed something up in an unexpected way. So this is what it looks like in the code, not necessarily in the code, but this is actually the query in SQL. So select everything from users where email. This is not the actual code, but this is actually the SQL query where email equals user, and then you have the password with a quote that actually terminates the quote that's being read from the input. So that actually terminates the input and then ultimately leads to the error. So enter the password and watch the code window. Enter the password like that, and watch the code window. So we should be watching over here. So you look at the logs again. Unable to log in this user to due to unexpected error rendering login page. Enter the password and watch the code window, which is what I did. The quote inserted directly into the SQL string, and that terminates the query early, as I've explained. This behavior indicates that the application might be vulnerable to SQL injection. Now, for developers, when you're dealing with SQL queries, it is best to use parameterized statements and to be able to actually escape user input as much as possible. Alright, enter the following credentials and click login. So in this case, we're going to have an authentication bypass. So user email and password quote or 1 = 1, and then you terminate this with comments. This actually means that whatever is after this, these two, like hyphens, is actually a comment. Now let's log in. In this situation, checking supplied authentication, finding user in database, authentication details confirmed, establishing session for this user. Now, what has actually happened here? So when you've supplied the password and they say we successfully gain access to the application without having to guess the password using SQL injection. So that's what they used. Now, what actually happened here in this situation, we have the same select all from users where email is an email and the password is. In this situation, we terminated the input, and then we just go into the code. So we terminated the input with a quote, and then we say or 1 = 1, which is always true, not through, and everything that's after that is a comment. So this statement always evaluates to true, and then actually makes this entire statement true. That actually leads to the login of the user. Now the hyphen characters, so let's go back. The hyphen characters you entered cause the database to ignore the rest of the SQL statement. So that's actually the comments that I've told you, allowing you to be authenticated without having to supply the real password. Now, we know, so now that we know how SQL injection works, now you know a very little part of how SQL injection works. You should also watch, so for free you can go onto my YouTube channel and watch all the SQL videos in the junior penetration tester path that I've done. I think there are like 4 or 5 videos, and those are more extensive. Now let's learn how to protect against this kind of attack. Now, so if we go into the lessons again, let's do a little bit of logistics here. SQL injection, we've seen the exercise, now we're into the prevention. So maybe we should start with this in the next video, with the prevention, and then go through the attack. I don't know. So SQL injection is a type of injection attack. These occur when maliciously crafted inputs are submitted by an attacker. Let's see how we're with the timer here. 13 minutes. Because of the ubiquity of SQL databases, SQL injection is one of the most common types of attacks on the internet. Well, it's still very common, but not as common as it used to be. If you only have time to protect yourself against one vulnerability, you should check for SQL injection vulnerability in your code bases. Yes, well, that's actually very true, because their impact is extremely high. It's extremely high, because if someone is able to dump your entire database containing all that sensitive information, that's a serious issue. Now, looking into the risks. What's the worst thing that could happen when you suffer a SQL injection attack? So extract sensitive information, as I've told you, enumerate the authentication details, that's also part of the extract sensitive information, delete data or drop tables, so modifying the database, which is extremely dangerous, and it might also go unnoticed if you don't have a lot of good checks in the back end. So if you don't do sufficient logging and monitoring, is one of the OWASP vulnerabilities. That's an issue. Inject further malicious code. So SQL injection attacks are astonishingly common. Well, They still are, but not as common as they used to be. Major companies have had their applications compromised. In other cases, attackers targeted specific applications or wrote scripts intended to harvest authentication details. Not even security firms are immune, of course. Want to see this vulnerability in action? That's what we did. Protection. So as I've told you, parameterized statements. So SQL databases, programming languages talking to SQL databases using drivers. A driver allows an application to construct and run SQL statements against the database, extracting, manipulating data as needed. So parameterized statements make sure that the parameters inputs, to be read as inputs, are treated in a safe manner. So a secure way of running a SQL query in JDBC using a parameterized statement would be this. So string SQL, select everything from users where email equals that, and then in this situation you have prepared statement STM connection prepare statement of SQL. So you're actually making a statement, so you're actually sort of like sanitizing or escaping, or actually sanitizing. You're sanitizing the prepared statement here, and then you can safely pass it. Contrast this to explicit construction of the SQL. So in this situation, you're just creating the statement. The string is email, connection con get connection user pass, and statement creates statement from the connection over here. So where's the email? I don't understand. Yeah, so in this situation you have the string SQL, select everything where email x email, you have the create statement, and you do not have the prepare statement. You're just creating it instead of preparing it. That's the issue. And then you're actually just executing it. Now, the key difference is the data being passed to the query method. In the first case, the parameterized string and the parameters are passed to the database separately, which allows the driver to correctly interpret them. In the second case, the full SQL statement is constructed before the driver is invoked, meaning that the vulnerable malicious code, meaning that we're vulnerable to malicious crafted code. Now, you should always use parameterized statements. So that's the number one protection. Another one, object relational mapping. So many development teams use ORM frameworks to make the translation of SQLs into code. ORM tools often mean developers will rarely have to write SQL statements in their code. So when you have SQL, if you're a penetration tester and you're actually reviewing code and you see SQL statements, that should actually sort of like ring a bell inside your head and actually draw you to be more careful, or to draw more of your attention into that, to actually analyze it more thoroughly. The most well-known ORM is probably Ruby on Rails, and in this situation, so a cookie like this, fetching data from the database using active records look like this. So you're defining a current user, and the parameter you're passing is an email. So the user object is an active record object in this situation that has a find methods, automatically generated by Rails. Now in this situation, find by email, so code is safe from SQL injection attacks. Now in this situation, if you're just not using the find that is generated by Rails, but you're actually using where, this will actually just take whatever is in the email parameter, in the email input field. And of course, as you can see, or as you can imagine, that's not actually safe from any perspective whatsoever. If you find yourself writing SQL statements by concatenating strings, think very carefully about what you're doing. And also, you're talking about escaping inputs. Now, that's why you will often see single quotes or double quotes in attempting SQL injection tags, because they're trying to actually escape the input. Programming languages have standard ways to describe strings containing quotes. Doubling up quote character or replacing this with this means treat this quote as part of the string not the end of the string. Escaping simple characters is a simple way to protect against most Sql injection attacks. So how you can do this? You need to be very careful to escape characters everywhere in your code base where Sql is constructed, if you actually run Sql statements in your code. Now, not all injection attacks rely on abuse of quote characters. For example, when a numeric ID is expected in a Sql statement, quote characters are not required. The following code is still vulnerable to injection attack no matter how much you play around with the quote. Now, sanitizing input. So again, we have parameterized statements, ORMs, escaping inputs, and sanitizing inputs. So the user supplied a password like this, which looks pretty suspicious. Developers should always make an effort to reject inputs that should not be expected, so to speak. Your application may clean parameters supplied in GET and POST requests in the following ways. Check the supplied field like email to match a regular expression. This is really good for emails. Ensure that numeric or alphanumeric fields do not contain simple characters. Now, with modern frameworks, you're actually pretty much solidly protected against this. Except the situations when you build the application yourself, not from frameworks, but from like code, from like the programming language itself. So instead of using, you would actually use barebone JavaScript instead of using React or Node.js, for example. Client-side validation is useful for giving. So, as I've said, this client-side validation is useful for giving the user immediate feedback when filling out a form, but there is no there's no defense against the serious hacker, because that serious hacker or penetration tester is actually going to start analyzing every input manually instead of using tools. Now, tools are very useful to actually get things or get your eyes on the right track, but not as a methodology in of itself. And of course, you have the code samples, good and bad practices when trying to protect against Sql injection. You have Python, of course. You have the good and the bad practice. You have in Django, of course. You have in Ruby, maybe not as interesting. You have in Java, but you do not. You have in Node.js, of course. They only show us the secured ways. Now there's always the dangerously set HTML function, and you have in PHP other considerations. Now let's see how we are with this video. We are 22 minutes in. Now what I'm going to actually do in the next videos is actually maybe taking things sequentially. So instead of going through the entire vulnerability in one video, I will go through the attack, defense, and then maybe the exercise in a separate video. So maybe 3 videos. Other considerations: principle of least privilege. So that actually means that principle of least privilege is actually sort of like you can view it as maybe through the lens of an allow or a block list. So when you create, or when a user is created, give that user no permission and just add permissions instead of give user all the permissions and then restrict the permissions subsequently. Just start with no permissions and then give permissions as they might be needed. Sensibly designing access management. So this is a whole video in of itself. No matter how the attackers get access to your system, it can mitigate the type of damage they can possibly do. Now, password hashing, in this case, this example was relying on the fact that the password was stored in plaintext. Unencrypted password is a major security flaw in of itself. Applications should store user passwords as strong one-way hashes, preferably salted. This mitigates the risk of users stealing credentials. And in this case, we're actually being sent to the glossary, as you can see. And third-party authentication is a situation you could use auth, OIDC, or other third-party authentications. These are good practices. Like I said, in future videos, in future videos for each vulnerability, I will make multiple videos to the vulnerability. Now, which of the following approaches is an effective way of protecting yourself against SQL? Frequently rotating your database passwords, moving your database to a separate server, using HTTPS, using parameterized statements. Using an object relational mapping tool will make you completely immune to SQL injection attacks. I would say false. SQL injection attacks always involve the attacker sending an unexpected quote character. Also false, because we remember the ID situation. Now 3 out of 3. Alright, so we have finished with the SQL. So SQL injection is all checked. In the next video we're gonna go into cross-site scripting and maybe just the exercise in the first video, the prevention, and maybe the quiz in the second video. Now with that being said, I'm gonna finish this video on 26 minutes here.